Okay, ladies and gentlemen, we're going to talk about parametric equations. Now, unlike a standard equation where you have y equals something x plus 2, blah, 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 that's y in terms of x, or a function in terms of x. What we're going to do now is we're going to have two equations, one x equation, one y equation, and they're both going to be in terms of some third variable, some other variable, for example, t. Okay? Now, the reason we even have something like this is because if I take something like a projectile and I have a cannon and out of the cannon fires the projectile, there are two things at play. At each point, you have an x dimension. So something is happening here, and this x can be in terms of time, whatever time it takes to get to this x amount. But at the same time, we also have something that's doing a y, and that y is in terms of some time. So at a particular time, 2 seconds after launch, 3 seconds after launch, you have a particular distance downrange, but you also have a particular distance up high. Now, of course, if we were to ask where does it land, we would say the y is going to equal 0 where it lands, but the time is certainly going to be some sort of positive number because it took time to get from here to here. The x, in addition, is also going to be some sort of positive number because it started at 0, 0 at time 0, so you have 0 for the x, 0 for the y, and time equaled 0. Now time has changed. Y is again 0, but x is something else. Additionally, if I have some sort of pendulum, and that pendulum is swinging back and forth, it's going to have two dimensions. It's going to have some sort of x dimension, and it's also going to have some sort of y dimension. But the difference is it's going to happen over and over. So it's going to be here once, twice, 3 times, 4 times, over and over and over. That's the idea of needing parametrics. In terms of conics, if I have something that if I look down on this, or if I have, for example, the sun, yay, sun, and we have the earth moving in some sort of elliptical pattern, okay, it's going to go around and it's going to end up in the same place, but it's going to be certainly a different time by the time it gets back around, or even specifically if you have the moon. And that's moving around over and over and over. You have both time and position. Now, given all of that, we have parametric equations. So we have x in terms of t and y in terms of t. To get this to move together, we simply need to potentially make a chart. Now, if I say, okay, there's x, there's y, well, it's x, it's y, but it's all in terms of t. Now, since we're going to use these two, let's start here at 0, 1, 2, 3. If I plug in 0 for t, I get 4. 1 for t, I get 5. 2 for t, I get 6. 3 for t, I get 7. Now, to find this, I plug it in and I get 0 squared negative plus 5. So at time 0, it's at 5. At time 1, it's at 4. At time 2, it is at 1. At time 3, it is negative 9, because remember, folks, the negative is out in front of the squared. So we have negative 9 plus 5, negative 4. If I begin to graph this, and we graph these components, we simply have 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1. 1, 2, 3, 4, 5, 6, 7. Negative 4. And you can see, depending on where we start, we could very well have part of a parabola going on, or maybe we have part of a hyperbola going on, although we don't have squared bits. Only one of them is squared, so we're more than likely going to have some sort of parabola. But you'll see at time 0, it's here. At time 1, it's here. And in fact, you can even put direction lines to indicate orientation. So these are parametric equations. T is the parameter. The angle, or the arrow, is your orientation. Now you say, well, what if I don't want parametric equations? What if I want to get rid of the parameters? Well, I can easily get rid of the parameters by simply solving this equation for t. So I have t equals x minus 4. Now everywhere I see t, I can plug in x minus 4. Y equals negative parenthesis x minus 4, quantity squared, plus 5. Now, I could go ahead and simplify that out and throw it all together, but I don't really have to. If I simply move the 5 across, and let's take the negative and let's put it on the other side, I have a parabola. And that parabola is going to be either up or down because it's x squared. Well, it's going to be down because it's negative. Its vertex is going to be at 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And it's going to be p value equals 1/4 because negative 1 equals 4p. And so now, if I take a look for p, and so p equals negative 1/4, I have the following. And in fact, it is this component that I found in my graph.